You have those skills. Okay, before I start, here's a flow chart that I gave you guys last sometime day. If you need to like cut it out and tape it onto your data sheet or something, if it helps you, let's walk through how to work with fractions. Step 1, factor everything. Everything. If it is factorable, you should factor it. The whole while you are doing this, you should also ask yourself the question, is now the opportune moment to cancel stuff? Because if there ever happens to be an opportune moment to cancel stuff, you should. I mean, I can't write that everywhere here, but like if there's something on the top and on the bottom of the same fraction, cancel it. Go ahead. So, next question then: are you dividing or multiplying? Multiplying is the easiest one. You just put the numerators and denominators together and you cancel stuff. That one's pretty straightforward. Dividing is just about as straightforward, except you take the second fraction, you flip it upside down. That's called multiplying by the reciprocal. Those two are not usually the worst. If you're not multiplying or dividing, it means you're adding or subtracting, and then you need to have common denominators, and that's a lot more of a challenge. If you're adding, you add the numerators together, but you keep the denominators. I have an extra little step here. If you're ever subtracting, you have to be super careful with that negative, because you have to make sure that negative applies to all of the things in the second term. That makes sense. And again, they all seem to end up at the same point: cancel. That's our goal when working with fractions. We're trying to cancel stuff. So we're now going to use those skills to solve. Well, to solve. Solving means there's now an equal sign. So basic premise: if you have a square root, what do? You square both sides at the opportune moment. In this particular example right here, go for it. Square root's by itself. So if we were to solve this, square this side, you'd just have just x plus 6. It would equal 4. You'd minus 6 from both sides. X would be minus 2. Ta-da! You guys okay with that? Yep. Okay. In order to solve a rational equation, the basic premise, you've probably heard this term before, it's called cross-multiplying. I'm guessing you've heard this term before. Okay, let me walk through what cross-multiplying means. In order to cross-multiply, you actually have to have the right conditions. The conditions are you have to have a fraction, and it has to equal another fraction. If there was a plus 1 over here, you can no longer cross-multiply. Does that make sense? So the conditions required for cross-multiplying is a fraction, a single fraction, has to equal another single fraction. And then you can cross-multiply, which means that you take this x plus 6, you swing it over there. You take the x plus 3, you swing it over there. So the 3 would go next to the x plus 3, and we'd foil that stuff. The 2 would go next to the x plus 6, and we'd also foil that stuff. Do you guys know why cross-multiplying is valid, by the way? Do you know mathematically what you're doing? Okay. Not that it matters so long as you know how to do it, but just so you know what cross-multiplying means. It means that you're timesing this side of the equation by x plus 3, and you're timesing the other side of the equation by x plus 3. If you times both sides by the same thing, mathematically that's valid. That makes sense? And what would happen then is this x plus 3 on the bottom and this x plus 3 on the top would then go away. And you're doing the exact same thing to the other side. So this x plus 6, you're going to times this side by x plus 6. You're going to times that side by x plus 6. And what happens is this x plus 6 right here will cancel with that x plus 6 right here. And then there's just one left on the other side. At the same time, though, teachers hopefully at some point have told you that it's called cross-multiplying. Does that make sense? So just the real key to cross-multiplying is make sure you only do it when you have fraction equals fraction. If you have fraction equals fraction plus a number, it doesn't work. Still doesn't work. It means you have to add those two fractions. So that's kind of my goal then, is let's kind of scaffold through some from easy to hard questions. So this guy right here, make it 3x plus 9, make it 2x plus 12, minus 2x, that goes away, minus 9, minus 9. That goes away. Ta-da. Did I do that too fast, or are you guys okay with that? Okay, so that's like level 1. About as easy as it can be. So let's walk through different challenges. Oh, by the way, here is the notes as to what you're doing. You're basically taking both denominators and you're applying them both to both sides. This one cancels here, this one cancels here. And effectively it looks like you're cross multiplying. So this is just a slide basically walking you through what I just said a minute ago. So, but for this to work properly, you must only have a single rational on each side. Okay, so here's an example I just found online. Just to make sure we understand the basic concept. We have a fraction equals a fraction. Can we cross multiply? Yes. This x went up top there. This x minus 6 went up there. So far so good. You then have binomials next to each other. I guess that's a monomial, but you foiled it all out. You foiled it all out. It gave you a whole mess of stuff right here. On this one here, it actually worked out well. The x squared's canceled. Bring the 4x to one side, bring that to the other side, and you solve. Okay. Okay. So let's try one of our own. First question, can you cross multiply? Why not? Yeah. Did I start recording this, by the way?
Yeah.
Okay, good. Okay, so hopefully it's clear. There's two fractions over here. So we need to draw back on previous skills. How do you combine two fractions together? Yeah, they need a common denominator. Before I even do that, maybe my first suggestion is let's factor everything. So you have 2 over top of whatever this guy factors to. X squared minus 4 is a difference of squares. Perfect. And I don't care what order you write those in, so that's fine. And then the second thing right here, the 6x plus 12, the only thing you can do is take out a 6. But it leaves you with x plus 2. Okay, I want to show you guys a trick that I use. This side of the equation over here, this right-hand side of the equation, we're not going to be doing anything with it for quite a while. So just to kind of save some room, I'm just going to try to draw an arrow down and say, we're just going to work with this side here for a while. This 1 over x minus 2, we're just going to hold off on it. Is that okay? So I'm just drawing an arrow there because I don't want to keep writing it every step because I got to spend some time over here on this side. Do they have entirely common denominators? Do they have partially common denominators? Okay. So we need to, I'll do it in colors here, make sure that everything happens on both parts. So like this guy right here is an x plus 2, this guy is an x plus 2, already good. I'll use a new color now. This guy right here has an x minus 2, this guy right here does not. So I times by x minus 2 on the top, and I times by x minus 2 on the bottom. That's valid because you're timesing by the same thing top and bottom. That's like a legal algebraic move. That makes sense. Now my x minus 2's are the same. One more thing I'm missing.
6.
Yeah. This guy right here has a 6. This guy right here does not, so I'm going to times by 6 on the top and on the bottom. Let's put a little dot in between there. So far, so good? All right. Now let's combine the numerator stuff. So 6 times 2 is 12. Does that make sense? And then this stuff right here, I should actually FOIL it out. And because there's a plus sign in between here, I don't have to be too careful. I can just continue writing stuff. But if there was a minus sign right here, be extra cautious. So 10 times x is 10x. And 10 times minus 2 is minus 20. And all of that goes over top of a big super fraction, which involves a 6, an x plus 2, and an x minus 2. One last step. The numerator, I can actually combine a few more things. I was kind of lazy. I could maybe have done it all in one step. what else could I do on the top there? Which are the... Yeah, so you can make it 10x minus 8. And that equals 6x plus 2, x minus 2. All right, now I'm going to bring down this 1 over x minus 2. Do we have the necessary conditions for cross multiplying? We have a fraction on the left-hand side. We have a fraction on the right-hand side. We now have the right conditions for cross multiplying. So I'm going to do so, and it'll look like this. The 10x minus 8 will get multiplied by the x minus 2 that was down here. And there's a 1 up top here, so that's kind of redundant. So I'm timesing by the 6. I'm timesing by the x plus 2. And I'm timesing by the x minus 2. You can. What do you want to cancel though? Yeah, Jamie noticed quite cleverly there's an x minus 2 on both sides. That would be valid to, I mean, technically what you're going to do then is you're going to divide this side by x minus 2. You're also going to divide this side by x minus 2, but you can remove those x minus 2s. This actually comes up on one of your questions on your assignment. The only way to solve it actually involved like, there was a cube root on one of the questions. I know some of you guys have done that, right? And you had to actually factor, and you could actually cancel it out. So what are you left with? Well, you're left with 10x minus 8, and you're left with 6x plus 12. Do you need a quadratic? Did I screw up?
Oh, no.
You did? Okay. It's not quadratic, so hopefully you can follow this. You're going to get 4x on this side and 20 on the other side. Divided by 4, x is 5. Let me know if I lost you there. Just kind of speeding through that last step. And that's our goal, by the way. Our goal is to solve and find what x equals, and we have what x equals. Okay, one more thought, though. It's always a good idea to check your work. I know it takes a second, but if you guys have learned anything so far this year, it's probably that where we're going in math right now is all about the little details. And if you're going to spend 10 minutes solving a question, and you're not willing to spend 1 minute to check your work, that's not smart. You know what I mean? So like, take the minute, check your work, because hopefully you'll find any dumb mistakes you make. So I'm just going to show you how I might do it in the calculator here if I have one. What did I say x was 5? Maybe I have to restart the calculator. So I might go 2 divided by, then I'm going to put a bracket for the whole bottom. I might go 5 squared minus 4. That takes care of the first fraction. And then I'm going to add 10 divided by new bracket for the bottom. And it's like 6 times 5 plus 12. Does that make sense what I'm doing there? So this is what the left-hand side is equal to. And then the other side would be 1 divided by bracket 5 minus 2. Ta-da! I'd recommend it. It takes you a minute. Check your work. I mean, you just spent 10 minutes doing the whole question anyways. What's in a minute? Because let's be honest, how many times is the only issue that you guys screw up and that you miss a minus sign, or you do something that you're like, right? So, I mean, my goal is to try to train that out of you. It's hard, right? But basically, stop making mistakes. If you can stop making mistakes, your grades will go up so much faster. Okay, how'd that go? Not bad. It's like not good. Like pH of 7, we're talking like, no? I don't know. Okay, I totally screwed up on this one. That's an X, by the way, not a Y. I would not make you have more than one variable. That'd be so mean. Oh my goodness, that'd be hard. The reason why there can't be a y there is that if you have two variables, you'd actually have to have two equations. So definitely a typo. Okay. Thoughts? Where should I start? Well, you know what? This stuff over here can be factored. So that's not a bad idea. But you know what? It's actually not necessary. Because really our more pressing goal is we want to cross multiply. Does that make sense? So as much as factoring would help, if we factored this right here, do you think it would actually cancel with something on the top? Probably not. I mean, this 18 can't cancel, so. Although factoring right here is plausible, it's not the most pressing concern. Our more pressing concern is that we cannot cross multiply until we have fraction equals fraction, and this side right here needs to go together. So why don't I start with that? Let's put an x minus 6 over an x minus 6 right there. I'll just use colors here. And let's put an x minus 3 over an x minus 3. Sorry that that's messy. I'm just going to kind of drop this guy way over here. There's a subtract sign between these guys. Be extra cautious. So the bottom of your combined fraction is now x minus 6 and x minus 3. And you know what? Maybe it's better actually to do this in the steps. 9 will times by x to give you 9x. And 9 will times by 6 to give you minus 54. I'm going to put a large negative sign in between these things, maybe just to keep it straight. Because then when I FOIL this next section out, you're going to have 4x minus 12.
Now can you do like the 9x minus the 4x and stuff?
Yeah, just make sure most of the time if someone makes a mistake, they do 9x minus 4x and they say that that's 5x, which is true. But then they do minus 54 and they subtract 12. But you're not actually subtracting because you're subtracting a negative, so you're actually adding 12. So it's actually minus 42. Thank you. Not 66. Does that make sense? Just be extra cautious with the subtract signs. So. Okay. That accomplished our most pressing goal. We now have a single fraction on the set over here. Do you know what though, Andy, I think it was you. You mentioned right off the bat that we can factor this little guy right here. So it wouldn't hurt to. It's just, the only reason I didn't start with that is that the left-hand side was a little more pressing. But why don't we try to factor that as well?
Harley Greer, can you please come to the office? Harley Greer, please come to the office.
We need numbers that multiply to give 18. No, multiply to give 18 and add to give minus 9. Yeah, there's actually a point I want to make on this question. Maybe you'll notice it. What's the point I'm trying to make? Yeah, that's the same denominators. I mean, you could cross multiply. That wouldn't be wrong. But, I mean, this is on one side. That's on the other side. They cancel. That is valid, by the way. This is on this side over here and on this side. The only reason that works, though, is they're both on the bottom of the fraction. If you had one on the bottom and one on the top, that wouldn't work. Does that make sense? But since they're both on the bottom, I mean, let's say you cross-multiplied this up here and this up here. You end up canceling it anyways. So 5x minus 42 equals 18. 5x will equal 60. X is 12.
Okay. Kevy Wells and Madeline Ola, please come to the office. Kevy and Madeline, please come to the office.
Hey, do you guys have a question? Yeah, come on in. I'm trying to find a way to make this work. So, how can I help?
This question.
Yeah, and then you're gonna have to like reduce that back down again. So like once you do 18 times 6 and make it whatever that number is, it's probably something that you can break back down into smaller pieces. The bottom, when you times root 6 by 6, will literally just be 6. Your blue teeth are like freaking me out here. Yeah, basically go like multiply these. Yes. Yeah. So then, you know, leave the square root stuff. So make this like 4 times 3, so make that 12. Make it 3 times 6, so make it root 18 and reduce it. Do the same thing here. This would be 5 with root 100. And then compare. Try to do it with square root still though. But yeah, that's how you compare. Alright. Any questions on this one?
Yes. How come, like, usually when we multiply, you can't, if we're multiplying and they're, like, on the same side, we couldn't cancel if it was on the bottom, but, like, only if it was on top.
Okay, so, like, I think I get what you're saying. Let me just check here. Let's say you had A times B, and it was A over B times B over C. That can cancel? Okay, but there was no equal sign. So what happens in this example here is because it's all on one big fraction, if it's on the same side, top and bottom can cancel. Okay. However, if they're on different sides, if you had A over B equals B over C, that would no longer work. Because what you'd be doing is you'd be cross multiplying your B up top here, you'd be cross multiplying your C up top here, and that's not the same thing. But if it was A over B equals C over B, what would happen then is, let's say you just didn't cross multiply this guy right here, just choose not to, times this B up here. Well, now look, now they're on top and bottom of each other, so now they cancel. Does that make sense? So you just gotta kind of, it's tough because there's a lot of rules, but if you can memorize what applies to each scenario. Because how many do I have left? Yeah, just 2 more. Okay. You guys ready for the next one?
You bet.
It's gonna be awesome. Okay. Let's see if we can do a whole bunch of things all in one step. Let's factor the right-hand side.
Madeline Orloff and Kevin Wells, please come down to the office.
Okay, let's factor the right-hand side, because that is helpful. But our more pressing concern is actually on the left-hand side, where we'd really prefer to have our common denominators fit together. Does that make sense? So, over here, what numbers multiply and add for the 4 and the 24?
Oh, no, never mind.
6 and 4, but that doesn't get us to 4. 3 and 8? Actually, you know what? I don't think that can be factored. So either I have the world's worst typo or this is on purpose, and I don't remember. So we're just going to go with it. Apparently the top cannot be factored. The bottom can. It's x plus 2 and x minus 2. Right? Yeah, 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6. No, none of those work. Okay. I really hope I didn't screw up. I would have noticed year after year. Okay, let's try the other side though. This guy right here, you're going to have to times x minus 2 top and bottom. And I know I'm kind of running out of room, but in here you got to go x plus 2 top and bottom. So your big superfraction is x plus 2, x minus 2, whichever order you want. It's the top of the fraction that we have to be cautious. Because of that negative sign in between them. So, I'll try doing colors just to maybe help keep it organized. X times 4x will give you 4x squared. Negative 2 times x, 4x will give you negative 8x. You'll also have a negative 1x, and you'll have a plus 2. Then a large negative sign between them. Hope I have enough room here. And then I gotta FOIL the other half. X times x is x squared. You'll have a 1x, you'll have a 2x, and 2. Oh, my neck is sore. I'm gonna sit here. to that step? Which one are you looking at? Up here? This is x squared plus 1x plus 2x and plus 2. Is everybody okay after that step? Okay. Be really careful with your subtracting now because, yeah, just be careful, I guess. So 4x squared minus x squared will give you 3x squareds. Okay, this is going to be tricky. You have minus 8, you're minusing 1 more, so that's minus 9. Then you're minusing 1 more, so that's minus 10. And you're also minusing 2 more, so I believe I've got minus 12 x's total. Make sense? And then here you have a plus 2 with another plus 2, but you're subtracting them, so they actually cancel. The bottom of the fraction is supposed to be x minus 2 next to another x plus 2. And that's equal to the stuff over here. Can I cross multiply? It could, but you guys get the point though. You can cancel the bottom. So, bye. Alright, what's left? A quadratic. Hopefully you can kind of see how the order to this unit kind of worked. We had to start with quadratics because often we need them to solve the other things we're working on, right? And I would say that like one of the reasons why I teach them in the order I do, we spent maybe a week on quadratics. And I don't know that other teachers would do it differently, but I'd say a lot of other teachers, they'd spend like 3 weeks on quadratics. And I'd prefer to spend 1 week on them because I know that if you didn't get quadratics when we first learned it, we're still going to be doing them later. Does that make sense? So it's one of those things where, like, if you didn't get the quadratic formula when we started, we're still using it here. So you're going to have 2x squared minus 8x minus 24. So either use the quadratic formula or factor if you are really brave. Quadratic formula?
Yeah.
Sure, let's do it. Minus 8 plus or minus the square root of minus 8, but we got to square that guy. 4 times 2 times minus 24 all over 2 times 2. Okay, minus 8 is just regular old positive 8. Just don't screw up the negative signs in the discriminant. Negative 8 squared is 64. And then you have like 2 negatives, so you're really adding whatever 4 times 2 times 24 is. So I got 256. And that's all over 4. Yeah, 256 square roots. 256 is apparently 16 when you square root it. Like evenly, like it actually square roots. If it actually square roots to an even number, what does that mean about our factoring back up here? Probably could have. That's all. If you didn't know, I don't care. It just means that, whatever. So it means we have 2 answers. We have 8 plus 16 over 4, whatever that is. And we have 8 minus 16 over 4. So is that 24 over 4 would be 6. And then 8 minus 16. Oh. True, do you still get 6? Because then it would be, so it would be 2 plus 4, which would be 6, or 2 minus 4. That makes sense. Good point. Yeah, since you can take 4 out of all of them, you could do that too. Because, yeah, 8 minus 16 would be minus 8 divided by 4. So. There we have our 2 answers. 6 and minus 2. Oh, I didn't get the point I want to make. I just need to undo this. Okay, so that was 6 or minus 2. You guys okay up to that point? Okay, twists. I think there's a twist on this one. Let's check our work. Yeah, one's extraneous. Jamie's caught it. Let's say you want to try checking your work. One of the answers was -2, correct? Try plugging -2 in right here. Well, -2 plus 2 is 0. Can you divide by 0? There is another way that you can get extraneous answers. Somehow you get a solution. The solution works, but the problem that you get is that you can't do something divided by 0. That makes sense? So that's another reason why you should always check your work. Not possible. So just 6. Is everybody able to see what I was talking about there? The -2. It's usually easy to pick out the extraneous ones. When you get your answer right here, if like this is x minus 2 or x plus 2 and you're trying to plug in -2, you should be able to see that like that won't work. I can tell you another answer that never should work. If x was ever positive 2, right here, positive 2 minus 2 would also cause a problem. So. Okay. Why don't you guys take a break, and then when you come back, we'll tackle the beast. I've taught you all the skills you need to solve this. Resume. Okay. Okay, so let me do the first steps with you guys. Let's deal with those negative exponents, because those are throwing you. Do you recall what a negative exponent means? No, a 1/2 means square roots.
Good try.
You're close. Here, I have a slide way back here. Let's see if I can find it. It's a ways back here.
Way back.
Oh, here it is. Okay. Goes on the bottom. Okay. This is hard to interpret, but if you have a square root, it's 1/2. Cube root is 1/3. Fourth root is 1/4. However, if you have a -1, put it on the bottom once. If you have a -2, put it on the bottom twice. If you have a -3, put it on the bottom 3 times. So, with that being said, then let's find our example. I'm only throwing those negatives in there just to mess with you guys. This 3x stays on the top, but the x plus 2 goes on the bottom. Twice, yeah. And so I'm just going to write it next to itself. While I'm at it, I'm going to do another step here. Whenever you see a divided by sign, just write a times sign and flip it. So a dot, and I'll flip this guy upside down. Okay, and then what about this last little thing right here? What does this mean? Well, the 3 is not in the bracket, so the 3 stays on top, but the x minus 4 goes on the bottom once. What if I gave you that? Was that more manageable to take a stab at? I'm going to give you guys like a 5-minute head start, and then I'll give you some tips and advice as you go.
So need more than 5 minutes.
I'm gonna guess you're like this is the first car right there.
Like I said, math is a collection of skills. Think of what skills you have. Factoring is a skill. Canceling is a skill. Combining fractions by adding them is a skill. Okay? Yeah. Can I sign your pencil in? So if you times by root 2 root 2, like you just have a 2 on the bottom. This 2 then flows into both of them. So you end up getting as 2 times 6 is 12. And this one I'm just going to skip here. 2 times 2 is just like a little 2 again. This 12 though gets broken down further. So you can read, 6 isn't good, but I'd say 4 and 3. Because then the 4 becomes a 2.
I agree that you have a 1 over x plus 2.
Okay, here's the math.
I'll write a letter.
However, you can just add these guys together here.
No.
The denominator here is both of these 2 things.
Why did I put that? No, see, there's the x minus 1.
You have minus these 3.
Yeah. At least I x minus 4. Why?
That
Right.
old crap right here.
It's 2 over x minus 1.
See how that works there?
This
So
is
these are almost right.
Then you have to
Except they're not really
you
supposed to
cannot
say
do
that
that.
that one's not, so you have to put that
Because
one
it's adding
here.
x.
And that's what you
I
try to
didn't
do.
cancel them out. Why is that happening? The top part.
What's going on over there?
Settle down!
I'm not talking to you.
You're screaming.
Okay, I'm gonna start throwing some work up on the board here. If you need, come take a look. I'll try to walk you through this.
I was writing first place. You just need cheater.
Wait.
See, that's 8.
So it's multiplied.
Yeah. I pulled this down. It's these two minus 4 minus 12.
Yeah.
I did this.
And then this was 7x.
So I just put that down.
Right.
I was writing first place.
And then 7 brings back and 4.
Yeah, that's why I multiplied. Oh my god, why did I have to show up?
Well, we're ready on that.
I enjoy it slow. Don't give me advice on that.
Okay, so here's the first couple of lines after where I left you guys last. Maybe just take a peek, make sure that you're with me. I know I've looked at a few of your works. You should be able to factor some stuff here. If you factor correctly, a bunch of stuff cancels. The 3x's can cancel, the x plus 2's can cancel. This x minus 1 though, and that x minus 1, they cannot go together yet. They will, but not yet. Because there's actually an extra x plus 2 right here. So you've got a term right here of this guy, and this guy, and you got a 2 over x minus 1. If you give them common denominators, you need to put an x plus 2 on the top and bottom. And it gives you 3x plus 7 over x plus 2, x minus 1.
What? How'd you get
Okay, so this 2x is 2x. With 1 more, there's 3x. And when you do 2 times 2, it's 4. Plus this 3 right here is 7.
I got
Okay, yeah, never mind. I get what you're doing. I just didn't realize what you're doing.
No.
I put a 6 here.
At this point here, you got to cross multiply, so it looks like this. 3x plus 7 next to x minus 4 equals 3x plus 2, x minus 1. Out of curiosity, anybody get that far? I know I've seen a few of you guys get that far.
We're done.
Yeah, well done. So then all you got to do is a bunch of foiling now. So let me just finish this off. Two x plus 3x plus 3x 6. You know what? This isn't actually quadratic, is it? Because there's 3 x's on both sides.
So they cancel.
They cancel out. You can actually solve this. I had originally intended, back at the top here, for you just to get to the point where you get a quadratic. But I guess you don't even need a quadratic because it's not even, like, it's linear. So, what do you got here? That'll be 7 minus 12 is minus 5. Minus 8x equals 22. Yeah, I've got negative 11 over 4. Anybody get that?
Yeah.
Well done, guys. Well, that's a pretty minimal help. Sincerely, if you could get all the way to the negative 11 over 4, that's brilliant.
Nice.
Or just a 3x plus 7.
I gave up because
It's a 3x plus 7?
Yeah.
Okay, so a line above here, you see how you have an x plus 3 right here? And then you have a 2 next to an x plus 2? So 2 times x gives you 2x. Add it to this x, 3x. 2 times 2 gives you 4. Add it to this 3, 7. That's where the 3x plus 7 came from. It came from adding all of this collective numerator. Okay, one last thought, then I'll shut up for the day. You guys have picked up on this by now. The littlest mistake blows your whole equation up, doesn't it? It happens, right? So, I don't have a great solution to that. Like if I'm not holding out on something, you know, but it's just one of those things where care and attention to detail is super critical, right? Like go slow if you need to. I would say that especially when you guys have written quizzes so far, I think almost everyone's had a little bit of time left over. Use it. You know, double check your math. Try not to screw up with negative signs or the little things, because that's how you get good at math. You stop making mistakes. I mean, to be honest, that's how you get good at anything.